Anthropic published a technical overview of Claude Code that wasn't supposed to be architectural documentation. It was 12 primitives, 3 tiers, and a design principle they buried in Section 4 that explains why Claude Code works the way it does. Claude Code is built on 12 architectural primitives organized into 3 functional tiers. The tool layer, what Claude can do; the state layer, what Claude remembers and tracks; and the quality layer, how Claude verifies and audits its own work. The most instructive design principle is metadata first. Claude Code reads and writes metadata about operations before executing them. This is how it can resume sessions, undo changes, and audit actions after the fact. The tool layer, the tool registry, is Claude Code's catalog of available capabilities: bash execution, file reading and writing, web search, code analysis. Every tool has a registration entry with its schema, what inputs it accepts, what outputs it returns, and what permission level it requires. The permission system sits above the registry. Before any tool executes, the permission system checks whether the current session has been granted the required level. The bash tool is the most powerful primitive. Unrestricted bash execution is the escape hatch that makes Claude Code general purpose. It is also the one that requires the most careful permission scoping. The state layer, session persistence, means Claude Code can be closed and resumed. The context of what was accomplished, what is in progress, and what files were modified is serialized and restored. Workflow state tracks the current position in a multi-step task, which steps are complete, which are pending, what the output of each step was. Token budgeting allocates the context window across the session, prioritizing recent and relevant content while compacting older context that is less likely to be needed. These 3 primitives together make Claude Code capable of long-horizon tasks that exceed a single context window. The quality layer, event logging records every action Claude Code takes: tool call, file read, file write, bash execution with timestamp, parameters, and result. This is the audit trail. 2-level verification. Claude Code verifies its own outputs at 2 levels. Syntactic correctness: does the code parse? And semantic correctness: does the code do what was specified? Transcript compaction maintains a summarized history that fits within the token budget. Permission audit trail is separate from event logging. It records every permission check, what was requested, what was granted, and who approved it. Together, these 4 primitives make Claude Code's actions auditable and reversible. Metadata first design is the buried principle. Before Claude Code writes a file, it writes metadata about the write, intended content, reason, expected outcome. Before it executes a bash command, it writes metadata about the command. This means the audit log is written before the action, not after. If the action fails, the metadata already records what was intended. If the action needs to be undone, the metadata records what state existed before. This is how Claude Code enables rollback, resume, and audit in a system that is fundamentally executing irreversible side effects. The 6 agent types Claude Code supports and what the architecture enables for each. Type 1, interactive, responds to human requests in a session, uses tool layer. Type 2, automated, runs a defined workflow on a trigger, uses state layer for position tracking. Type 3, parallel, multiple instances on different subtasks, uses session persistence for coordination. Type 4, reviewer, reads code and checks for issues, uses verification layer without execution. Type 5, specialist, one narrow tool with deep expertise, minimal permission scope. Type 6, orchestrator, coordinates other agents, uses workflow state for multi-agent position tracking. Each type uses different primitives. The architecture is designed to support all 6 without architectural change. What this architecture enables that naive implementations miss. Naive, one long session until context limit, then restart. Claude Code transcript compaction continuously maintains a working context that spans arbitrarily long sessions. Naive, no record of what changed. Claude Code metadata first means pre-state is always recorded before any write. Naive, permissions are all or nothing. Claude Code permission system allows per tool, per session. Per tier granularity. Naive, multi-agent requires custom coordination code. Claude Code, workflow state and session persistence make coordination a platform feature, not a custom implementation. Here is what the evidence shows. Your turn, look at your Claude.md file or create one if you don't have it. Map what it does against the 12 primitives. Is it defining tool permissions? That's the permission system layer. Is it defining workflow steps? That's the workflow state layer. Is it defining quality criteria for outputs? That's the verification layer. The Claude.md is your interface to Claude Code's architecture. If you understand the 12 primitives, you know what to put in it and why each instruction matters. What Anthropic leaked about Claude Code's architecture.